Hello, Barbara O'Neill. I am addressing you personally here. And the reason I'm doing this is because I would like to make a plea to you. Because I would like to hear some explanations. I was going to write about this, but the written word is often misconstrued. And people sometimes read a written word with a tone of voice, that they put into it. And it could be an angry one, it could be offensive. So I wanted to address you heart to heart because I have deep respect for you and the work that you do. I have learned so much from you. And I have, by the way, met Michael in Canberra 2 years ago. He's a lovely man. You're all a lovely family. And I have deep respect and appreciation for the work that you do. But I do have to be honest with you because I do feel a little bit uncomfortable about some of the statements you make. You see, I am an agricultural scientist and specializing in chemical issues, of soil fertility and stuff like that. And I have a very deep interest in nutrition and welfare. And I have expressed some concerns with some friends about some of the things you said. And they said to me, well, in a way that implied, well, who are you to disagree with Barbara? And yes, who am I? Who am I? I'm not a health professional. Okay, but I do know about chemistry and I do know about biology. And I didn't know how to address you. I don't have your email address, and I'm sure you receive hundreds, maybe thousands of them. So for me to address you here publicly is probably the only way that I can canvass a response from you. Okay, so I'm going to try to, and please don't get this wrong here. I'm not trying to put you on the spot. I'm just trying to get some explanations. So I just want to unpack, like an interview that you've done some time ago. So if we can play it here on my PC and then we'll stop and I'll make some comments. Okay, play please.
You are big on Celtic sea salt. You love Celtic sea salt. You take it regularly. Can you explain exactly the method? Is it something that you put in your water? Do you put it in your mouth first? How exactly can somebody take Celtic sea salt?
Okay, so let me explain it. And I got this information from a few sources, and one of the sources is Dr. Robert Thompson, who wrote the book, The Calcium Lie. And he believes the clearest indicator of a creator God is seawater, because seawater has 92 minerals, the exact same mineral and proportion and balance as is found in the body. And the closest to seawater is Celtic salt. Celtic salt has 82 minerals.
Stop. Okay, Celtic salt has 82 minerals. Yeah, well, that's possible. But I'm not sure really if this is something to brag about or to be concerned of. You see, in the periodic table, when you look at the periodic table, you see each element has got a number on the top left. Hydrogen has 1, helium 2, then lithium 3, beryllium 4, etc., etc. And this number represents, or is known as the atomic number, which is the number of protons and electrons in the atom of each cell, in the nucleus of each atom. And this atomic number goes up from 1 to about 100, roughly. So we have about 100 elements that are existing in nature, out of which everything else is made. Now, the heavy metals are called heavy metals for a reason, because they've got a big nucleus. So they've got atomic numbers like from 40 and above. And not all of them are toxic. In fact, like selenium, iron, molybdenum, copper, they're heavy metals, but they are essential. And in fact, there are some non-heavy metals that are toxic, like aluminium, for example. But anyway, let's not digress here. So when we say that the Celtic salt has 82 minerals, then it must have encroached down the periodic table into the area of heavy metals, which, as you know, are subject to bioaccumulation. So to say that it's got 82 minerals in it is not something that's necessarily good. Not at all, not in my view. If you can explain this, that I'm wrong, please do. Play.
And Dr. Robert Thompson says, if you put a little crystal of Celtic salt on your tongue before every glass of water, He says all you're doing is replacing the minerals you lost yesterday in your urine, in your perspiration, in your bowel movements. So how big is the crystal of...
Sorry, I stopped here prematurely, but that's okay. We'll hear it in the next video. You're saying a crystal of salt, which you will later on, stopped you here prematurely, before you said that it's the size of a sesame seed. Okay. Now, according to the research that I have done, there are different figures about, let's just talk about one element here, magnesium. We lose about 3 to 5 millimoles per day of magnesium, which is equivalent to 65, say 60 to about 100, or let's say 80 on the lower range. 60 to 80 milligrams of magnesium a day in the urine. And Celtic salt has like 4% magnesium, right? So what's the weight of a sesame seed? 2 milligrams? How is it possible that it can replace let's look at the lower level. How is it going to replace the 60 milligrams of magnesium that we lose in urine? Please explain. Play.
Celtic salt, probably about the size of a sesame seed. If someone's not used to salt, I think I'd advise even less than that to get their body used to it. Celtic salt is a very wet salt because it has 3 magnesiums, and magnesium is...
Stop. 3 magnesiums. What are they? When I look at the periodic table, there's only one magnesium, one element called magnesium. Okay, you may be referring to 3 magnesium salts, but sorry, no offense, but if you want to talk professionally, you have to use proper terms. You can't say 3 magnesiums. You can say 3 magnesium salts. That would be more acceptable. But even if we say 3 magnesium salts, that's still really not very accurate, because when things are in solution, when you have a mixture of salts in solution, you have a whole array of cations and anions mixed together with an electric balance. The negative charges will always have to be equal to the positive charges. So if you have a mixture of, let's say, the cations of calcium, sodium, potassium, magnesium, let's say only these 4, mixed with the cations of chloride, fluoride, iodide, sulfate, nitrate, okay? So you've got 4 or 5 anions, 4 or 5 cations. You can't really categorically say that I have sodium chloride here or magnesium chloride. If you want to talk technically, it's a mixture of all of these things. So, and the only way to ascertain that really that salt, you're talking about the Celtic salt, has 3 different types of magnesium, would be to do an X-ray diffraction study on the shape of the crystals, because when it crystallizes, it may bind itself to either chloride or sulfate or phosphate. I don't think this kind of study has been done. And why would they do it? There's no need to do it. It costs thousands of dollars and it's futile. So to say there's 3 magnesium in Celtic salt or anything else is technically incorrect. Sorry, unless you can explain it to me. Again, I'm not trying to be sarcastic here or cynical. I'm just asking questions. Play.
Is a water-hungry molecule.
Stop. Magnesium is not a molecule. Magnesium is an element, and the smallest particle of it is an atom. And when it's in solution, this atom loses 2 electrons. It becomes magnesium plus plus, and it's referred to as magnesium ion. So when you say magnesium is a hungry water molecule, I'm just talking about here the final definition of it being a molecule. This is grossly incorrect. It is not a molecule. Now, I'm going to talk about the water-hungry part of it later on. So if we can play, please.
So when you put that crystal on your tongue and then drink your water, The mucous membranes in your mouth absorb those minerals, take it to the cell, you drink your water, and that water-hungry molecule, magnesium, actually pulls that water inside the cell.
Stop. Okay. Now, there are two main ways of things to go across a biological membrane, depending on the nature of the membrane. So you either have diffusion, which happens across a totally permeable membrane, or osmosis, which happens across a semi-permeable membrane. And a semi-permeable membrane, for those who are not familiar with the term, is a membrane that allows certain chemicals to go through it and not others. Okay, but in both instances, the movement happens from a medium of high concentration to a medium of low concentration. And in biological sciences, we refer to this as the concentration gradient. It's just like how in nature things fall from high position to low position by virtue of gravity. So this is a natural process. This is, again, in biology, is called a passive process. Passive as in, meaning that it doesn't require the expenditure of any energy because it's happening spontaneously. And water is one of those molecules that goes across membranes passively. It doesn't need active transport. It doesn't. Water is the carrier. It doesn't need anything to carry it. And if you add something to it, you're actually making its concentration less, and you're making it more difficult for it to go across membranes. Not the other way around. Hang on, no. I don't think we're going to play anymore. So to say that magnesium is helping water go across the cellular membrane, I need to see an evidence of it. You see, in nature, again, we have active transport, as I mentioned before, and there is moving of particles against, this concentration gradients. That's why we have things like ionophores, to help carry those ions across. Like in the kidneys, you have the first phase of in the Henle's loop, where you have total, diffusion of minerals from the blood to the urine, and they get reabsorbed in the ascending column. They get reabsorbed against the diffusion gradient, and that's an active process, which makes sure that we don't lose too many of these minerals, with the urine. So that's one of the body's way to deal with nutrition frugally. So you don't want to lose as much as you would have otherwise if you didn't have this reabsorption process. And I'm not telling you anything you don't know. So when we say that, or when you say rather that magnesium is a hungry water molecule, in essence, in a way, it is water hungry, even though it's not a molecule, because it likes to be hydrated. And this is why, when people want to, let's say, clean their bowels without having to use any of those nasty medications, they would go and OD themselves on Epsom salt. Because Epsom salt, magnesium sulfate, will absorb a lot of moisture, and it will cause, looseness in the stools. You got that? It's absorbing the moisture to itself. It's taking it away. If you put magnesium outside a cell, it's going to draw water from the cell to hydrate itself. It's not going to push water into the cell. Sorry, correct me if I'm wrong. Show me the evidence. I'm more than happy to change my mind. Now, why am I saying all of this, Barbara? Because I have deep concern. I love you guys, and I would like to see that everything you say is well researched. And it's okay if you don't have a strong background in chemistry, and this is very obvious. I'm sorry, it's really very, very obvious that you don't have high school knowledge of chemistry. With all respect, I'm saying that. You don't need to be a chemist to be a naturopath. That's fine. But when you want to talk about things, unless you can prove me wrong, but you can't, I don't think, prove me wrong when it comes to the amount of magnesium we lose in urine versus the amount of magnesium that's in that sesame seed lot of Celtic salt. So we have to, if we want to fight the mainstream and its lies, if we want to fight fake science, we cannot fight it with another fake science. Two wrongs don't make it right. I have always said that. We have to be truthful to ourselves, to our listeners, and to the wider community. That's one thing. The other thing, some people, because they love you so much and trust you so much, they're taking your word to an extreme. They're throwing away their blood pressure medication and they're replacing it with Celtic salt. And they're adding, I know you're not saying that. You're not saying to them, do that. But that's what they're doing. They're adding a teaspoon of salt to every liter of water they drink, of Celtic salt. So they're taking, 15, 20 grams of Celtic salt a day. Now, if they're prone to high blood pressure, I think this is a dangerous practice to have, more so dangerous than perhaps quitting the blood pressure medication. I don't know, I'm not a medical doctor. So all I'm saying to you here, Barbara, is please to listen to this with an open heart, open mind, and please understand that it's coming from love. And the only reason I did this publicly is, again, because when I say what I have just said to people, they say to me, well, who the hell are you? Barbara O'Neill is saying this. So I'm prepared to put my name and face to it and face the humiliation of being proven wrong. There's nothing that I would love to face now more than the humiliation of proven to be wrong. So the ball is in your court. Thank you so much.